Hi, this is the presentation for Project 3 from Group 13. My name is David Neer.
I'm Dariesky Linares.
I'm Yoelmir Santana. We'll be presenting warehouse robots.
Warehouse robots serve many purposes. Warehouses in general are large workspaces, and the robots can be used for moving cargo around the large areas. They were mainly introduced to increase the efficiency that you wouldn't find when you're using mainly manpower. The costs for running the robots are usually less. They have initial higher investment. However, the overall cost would be less since robots can be more efficient and they don't need to take breaks. They don't take vacation time, and so that they can work longer hours and keep productivity up. The different types of robots that you'll usually find when you're in a warehouse are gantry robots, there are robot arms, there are also automated storage and retrieval robots, along with automated guided vehicles. And in the next slides, we will talk about these robots in more detail.
Gantry robots. Gantry robots are used in warehouse where they don't have a lot of floor space because these robots are basically located on the top of the warehouse. They are good for stacking different sizes of packages, and they work in different ways. Robot arms. Robot arms have a very complicated design, and they can be used to do the different tasks. They are very expensive to make and design, but once you have it, then it's very
Automated storage and retrieval systems is basically a system similar to one you see here. This is basically a 2D system, but what it does is it's a robot working two prismatic actuators and three-body joints, and basically it stores cargo in cubicles. For example, in this, an implementation of this is, for example, this IKEA storage facility. Basically, they put the pallets in, and basically the system gives a coordinate system to every pallet, and when you need to retrieve the pallet, you just input the code, and the robot by itself goes to the location of the pallet in 3D Cartesian coordinates system and retrieves it and puts it on, and basically that's how the system works. It gives basically, unlike gantry system, which stacks things on top and doesn't let you reach what's on the bottom. This system allows you to have access basically in all particular boxes independently, while reducing space to manipulate this cargo between the cubicle areas. Okay, another system we see a lot we've seen lately a lot, it's the automated guided vehicles. These vehicles basically work by putting a grid in the floor, so though the floor looks stuck, it looks like a regular floor, it actually has embedded little sensors, so or units that basically tell the robot in a grid way in which particular part of the warehouse they are located, and that way they know their way around. This is the implementation on a forklift type robot. So as you see, it works with regular pallets, conventional pallets, and it works on the same way as it's basically an automated forklift. This other design, which is made by Kiva, it's basically gets underneath the cargo, the pallet, and carries the load from the bottom. So in essence, you're moving all the cargo around, so it saves more space compared to the forklift. However, it requires custom-made pallets in order to work properly.
The tasks to be completed by robots in a warehouse can, of course, vary widely. However, this being a common setup that you would find in warehouses where you have many rows of pallet racks where the cargoes will go on the different racks. That being said, the main task that we wanted to accomplish was to be able to retrieve and store cargo. And in addition to that, we wanted to be able to retrieve them in no specified order. So we didn't want to have to follow a last in, first out type of setup or anything specific like that, so that according to the needs of the customer or for the company, we would be able to follow up along a setup like this in order to retrieve that cargo. And the cargo would be retrieved by the end effector after the robot gets to the specified location.
Different solutions that we could implement in order to solve these problems are basically a combination of any of the previously shown designs. However, since our class was limited to arm joint robots, we were limited to arm with joint robots, whether they are rotational or prismatics. We also were specified to use a 3 degree of freedom robot, so we were limited on that basis too. The two main designs we considered were basically a robot arm with 3 rotational joints. This is a very articulated robot. It's very versatile. However, the robot has only a circle reach area that it can work in. Also, since the way, due to its geometry, every time it moves, you have to have an effector that overcomes the tilt, the change in angle that is induced by the geometry of the robot. Also, they're hard to program, expensive, and then even though they carry large loads, they're not really, their load capacity is rather low compared to, for example, an arm prismatic, 3 prismatic joints, which is the other design we decided to look at. These systems are rather simple. These Cartesian coordinates, and they're simple to program, have a higher load capacity, and covers space in a cubic way, which is what you need when you're using boxes and cubic geometries. Okay, the final choice we chose, of course, was a 3 prismatic joints arrangement. This final arrangement allows our cargo to be particularly accessed as specified, and it works very similar to the 2D automated retrieval system we saw before. In this case, it works in 3D, so it allows the robot to access different roles, unlike the sample we showed before. And in the next video, we'll see how this looks. This is basically an animation of how the system will work in SolidWorks. And as you can see here, it's accessing this row, but it can access this other. The effector is in charge of retrieving, moving the pallet from the gantry to a system, and then it will deliver the cargo from any of these gantries to this point where it can be taken care of.
The future of the industry. The future of the industry will be basically everything will be automated. Human interaction will be less and less ultimately. The robots will do everything on the factory without any need of people. That concludes our presentation for warehouse robot. Thank you.